Hi, I am Teacher Daisy. Now, let's learn Form 5 Mathematics Chapter 6, Ratios and Graphs of Trigonometric Functions. In this chapter, you will learn 6.1 the value of sine, cosine, and tangent for angle, 0 degrees less than or equal to theta less than or equal to 360 degrees. 6.2 the graphs of sine, cosine, and tangent functions. 6.1 the value of sine, cosine, and tangent for angle, 0 degrees less than or equal to theta less than or equal to 360 degrees. A unit circle is a circle that has a radius of 1 unit and is centered on the origin. If theta greater than 0 degrees and theta less than 90 degrees, then theta is in quadrant 1. If theta greater than 90 degrees and theta less than 180 degrees, then theta is in quadrant 2. If theta greater than 180 degrees and theta less than 270 degrees, then theta is in quadrant 3. If theta greater than 270 degrees and theta less than 360 degrees, then theta is in quadrant 4. Relationship between the function of sine, cosine, and tangent for angles in quadrants 2, 3, and 4 with the corresponding reference angle. The corresponding reference angle, alpha, is always less than 90 degrees. Angles in quadrants 2, 3, 4 have corresponding reference angles, alpha. The angle in quadrant 1 itself is the corresponding reference angle, alpha equals theta. Quadrant 1, alpha equals theta degrees. Quadrant 2, alpha equals 180 degrees minus theta degrees. Quadrant 3, alpha equals theta degrees minus 180 degrees. Quadrant 4, alpha equals 360 degrees minus theta degrees. Remember the 4 letters ASTC by all students take chemistry. Quadrant 1, all sine, cos, and tan theta positive. Quadrant 2, sine theta, equals positive sine alpha, equals positive sine, 180 degrees minus theta, cos theta, equals negative cos alpha, equals negative cos, 180 degrees minus theta, tan theta, equals negative tan alpha, equals negative tan, 180 degrees minus theta. Quadrant 3, sine theta, equals negative sine alpha, equals negative sine, theta minus 180 degrees, cos theta, equals negative cos alpha, equals negative cos, theta minus 180 degrees, tan theta, equals positive tan alpha, equals positive tan, theta minus 180 degrees. Quadrant 4, sine theta, equals negative sine alpha, equals negative sine, 360 degrees minus theta, cos theta, equals positive cos alpha, equals positive cos, 360 degrees minus theta, tan theta, equals negative tan alpha, equals negative tan, 360 degrees minus theta. Example: determine the quadrant and the corresponding reference angle for each of the following. A. 138 degrees. 138 degrees is located in quadrant 2. Corresponding reference angle, alpha equals 180 degrees minus 138 degrees, equals 42 degrees. B. 239 degrees. 239 degrees is located in quadrant 3. Corresponding reference angle, alpha equals 239 degrees minus 180 degrees, equals 59 degrees. Example: state the relationship between each of the following trigonometric functions with its corresponding reference angle. A. Sin 167 degrees. B. Cos 258 degrees. C. Tan 349 degrees. A angle 167 degrees is located in quadrant 2. Sine theta equals sine 180 degrees minus theta, sine 167 degrees equals sine 180 degrees minus 167 degrees, sine 167 degrees equals sine 13 degrees, only sine theta is positive. B angle 258 degrees is located in quadrant 3. Cos theta equals negative cos theta minus 180 degrees, cos 258 degrees equals negative cos 258 degrees minus 180 degrees, cos 258 degrees equals negative cos 78 degrees. C angle 349 degrees is located in quadrant 4. Tan theta equals negative tan 360 degrees minus theta, tan 349 degrees equals negative tan 360 degrees minus 349 degrees, tan 349 degrees equals negative tan 11 degrees. Relationship between the values of x-coordinate, y-coordinate, and the ratio of y-coordinate to x-coordinate, with the values of sine theta, cos theta, and tan theta. Sine theta equals y-coordinate, cos theta equals x-coordinate. Tan theta equals y-coordinate over x-coordinate. In quadrant 1, all positive, thus, sine theta equals positive y, cos theta equals positive x, tan theta equals positive y over x. In quadrant 2, only sine positive, thus, sine theta equals positive y, cos theta equals negative x, tan theta equals negative y over x. In quadrant 3, only tangent positive, thus, sine theta equals negative y, cos theta equals negative x, tan theta equals positive y over x. In quadrant 4, only cosine positive, thus, sine theta equals negative y, cos theta equals positive x, tan theta equals negative y over x. Example: each of the following diagrams shows a unit circle and angle theta. Determine the values of sine theta, cos theta, and tan theta. A. Sine theta equals 0.8829. Cos theta equals 0.4695. Tan theta equals 0.8829 over 0.4695 equals 1.8805. B. Sine theta equals negative 0.5446, cos theta equals negative 0.8387, tan theta equals negative 0.5446 over minus 0.8387 equals 0.6493. Example: determine the value for each of the following based on the corresponding reference angle. A. Sine 104 degrees, B. Cos 208.2 degrees. A. 104 degrees is in quadrant 2. Sine values are positive in quadrant 2. Sine 104 degrees equals positive sine 108 degrees minus 104 degrees equals positive sine 76 degrees equals 0.9703. B. 208.2 degrees is in quadrant 3. Cosine values are negative in quadrant 3. Cos 208.2 degrees equals negative cos 208.2 degrees minus 180 degrees equals negative cos 28.2 degrees equals negative 0.8813. Determine the value of sine, cosine, and tangent for angles in quadrants 2, 3 and 4 corresponding to angles 30 degrees, 45 degrees and 60 degrees. Consider an equilateral triangle, with side of 2 units. To help you remember, sine goes 1, 2, 3, and cos goes 3, 2, 1. Example: without using a scientific calculator, determine the value for each of the following, based on the corresponding reference angle. A. Cos 150 degrees. B. Tan 225 degrees. A. Cosine values are negative in quadrant 2. Cos 150 degrees equals negative cos 180 degrees minus 150 degrees equals negative cos 30 degrees. B. Tangent values are positive in quadrant 3. Tan 225 degrees equals positive tan 225 degrees minus 180 degrees equals positive tan 45 degrees equals 1. Determine the angle when the value of sine, cosine, and tangent are given. Identify the quadrant, based on the positive or negative sign, on the value of trigonometric function. Determine the corresponding reference angle. Calculate angle theta based on the quadrant identified. A. Given that sine theta equals 0.6157 and 0 degrees less than theta less than 360 degrees, calculate angle theta. B. Given that cos theta equals negative 0.4226 and 0 degrees less than theta less than 360 degrees, calculate angle theta. C. Given that tan theta equals negative 1.4826 and 0 degrees less than theta less than 360 degrees, calculate angle theta. A. Sine theta equals 0.6157, positive sign. Theta is in quadrant 1 or 2. Corresponding reference angle equals inverse of sine 0.6157 equals 38 degrees. Theta equals 38 degrees, or 180 degrees minus 38 degrees equals 38 degrees or 142 degrees. B. Cos theta equals negative 0.4226, negative sign. Theta is in quadrant 2 or 3. Corresponding reference angle equals inverse of cos 0.4226 equals 65 degrees. Theta equals 180 degrees minus 65 degrees, or 180 degrees plus 65 degrees equals 115 degrees or 245 degrees. C. Tan theta equals negative 1.4826, negative sign. Theta is in quadrant 2 or 4. Corresponding reference angle equals inverse of tan 1.4826 equals 56 degrees. Theta equals 180 degrees minus 56 degrees, or 360 degrees minus 56 degrees equals 124 degrees or 304 degrees. 6.2 The graphs of sine, cosine, and tangent functions. Characteristics of the graphs. Sine graph, y equals sine x, has a maximum value of 1 when x equals 90 degrees, and a minimum value of -1 when x equals 270 degrees. Intercepts x-axis at x equals 0 degrees, 180 degrees and 360 degrees, x-intercept, intercepts y-axis at y equals 0, y-intercept. Cosine graph, y equals cos x, has a maximum value of 1 when x equals 0 degrees and 360 degrees, and a minimum value of -1 when x equals 180 degrees. Intercepts x-axis at x equals 90 degrees and 270 degrees, x-intercept, intercepts y-axis at y equals 1, y-intercept. Tangent graph. Y equals tangent x. Maximum value is infinity, and minimum value is negative infinity. Intercepts x-axis at x equals 0 degrees, 180 degrees and 360 degrees. X-intercept. Intercepts y-axis at y equals 0, y-intercept. The values of tan 90 degrees and tan 270 degrees are undefined. Effects of changes in constants a, b, and c on the graphs of trigonometric functions. Y equals a sine bx plus c, y equals a cos bx plus c, and y equals a tan bx plus c. A periodic function has period and amplitude. Period is the interval of one complete cycle. For example, the graph of sine function repeats itself on an interval of 360 degrees. Amplitude is the maximum distance measured from the center line. For sine and cosine, when a changes, the maximum and minimum values change. The value of a affects the amplitude of the function. Amplitude of function equals a. For tangent, when a changes, graph curvature changes. There is no amplitude in tangent graph. When the value of b changes, the value of b affects the period of the function. When b changes, the graph will be compressed or expanded. B increases, the graph appears to compress horizontally, the period of the function decreases. The period of sine and cosine functions equals 360 degrees over b. The period of tangent function equals 180 degrees over b. When the value of c changes, the value of c affects the position of the graph of the function. When c changes, the graph will move vertically up or down. When c greater than 0, the graph moves c units vertically up the x-axis. When c less than 0, the graph moves c units vertically down the x-axis. Example: the diagram shows a graph of the function y equals sine x for 0 degrees less than or equal to x less than or equal to 360 degrees. Sketch each of the following trigonometric functions on the same axis. Solution: a, y equals 2 sine x, a equals 2. Amplitude becomes 2. b, y equals sine 2x, b equals 2. Period becomes 360 degrees over 2, equals 180 degrees. c, y equals sine x, plus 1, c equals positive 1. The graph moves 1 unit up. d, y equals 2 sine 2x, a equals 2. Amplitude becomes 2, b equals 2. Period becomes 360 degrees over 2, equals 180 degrees. Example: sketch each of the following trigonometric functions for 0 degrees less than or equal to x less than or equal to 360 degrees. a, y equals 2 cos x, plus 1. b, y equals tan 0.5 x minus 1. Solution: a, y equals 2 cos x, plus 1, c equals positive 1. The graph moves 1 unit up. A equals 2. Amplitude of the function is 2. b equals 1. Period of the function is 360 degrees. b, y equals tan 0.5 x minus 1. c equals negative 1. The graph moves 1 unit down. Tangent graph does not have amplitude. b equals 0.5. Period of the function is 180 degrees over 0.5, equals 360 degrees. The concept map of Form 5 Chapter 6 is as below.
If you find this video helpful, don't forget to like, share and subscribe our channel. And if you got any question can comment below. Thanks for watching.